Welcome now to the Unit 3 review, which was all about graphing parabolas. So here's our equation in vertex form. The first number is the a value. The second number is the h value with the opposite sign to what it looks like. The third number is the k value. So what you want to remember is the direction of opening is down, and that's because a is less than 0. If the a is negative, it opens down. If it's positive, it opens up. The vertex is at hk, and the h is the opposite number to what it looks like, so it is at 3, 7. So there's your vertex at 3, 7. The axis of symmetry is the imaginary dotted line that would go through the vertex right there. Since it's a vertical line, its equation is x equals, and what x equals is whatever the x value is, which is 3. The max-min value, that is the y value of the vertex. So that's at y equals 7. That's going to be a maximum because your parabola is going to be opening down, which means you're going to have a high point. And the transformations. So we've got 4 transformations. The negative is going to make it reflect over the x-axis. The 2, since that number is bigger than 1, will make it stretch. If the number was less than 1, it would be a compression. Stretch vertically by a factor of 2. The 3 is going to shift your graph right 3. Remember, that's a positive 3 because the negative goes with the equation, not the 3. And the 7, since it's positive, will shift up 7. So those are your transformations. Now, in order to graph this, what you want to remember is that the normal step pattern is 1, 3, 5, 7, etc. And we're going to multiply this with the a, which is negative 2. So our step pattern is going to be negative 2, negative 6, negative 10, negative 14, etc. So from the vertex, we're going to go over 1, down 2. Then over 1, down 6. And then over 1, down 10. If it goes off the grid, you don't really have to graph it. And the same on the other side. Over 1, down 2. Over 1, down 6. Over 1, down 10. And then you do your very best to graph this. Give you some benefit for shaky hand syndrome, especially trying to graph it on this tablet is very challenging. Just make sure your vertex is not at a point, that it's kind of rounded. And make sure that your graph goes all the way to the end of the grid and you plot as many of the points in the step pattern as you can. So that is graphing a parabola. Next of all, you have to be able to tell from the table if it's a linear, quadratic, or relationship, or neither. So we start with the first differences. That means you take 25 and subtract 15, and that gives you 10. 15 subtract 9 is 6. 9 subtract 7 is 2. So that means it's not linear. Because if it was linear, all of the first differences would be equal. Now calculate the second differences, which means we take the first differences of the first differences. So 10 minus 6 is 4, 6 minus 2 is 4, and because the second differences are equal, that means it's a quadratic relationship. So that's how you determine if it's linear or quadratic from a table. The last thing you need to know from this unit is how to get the equation of a parabola if I give you the vertex and the point that it passes through. So the equation in vertex form is this. So in your vertex, that's your h and that's your k. So we're going to substitute those in. And remember, when it's x minus negative 8, it's going to be x plus 8. Now, to determine the a value, you're going to substitute this extra point in for x and y. So the negative 48 goes in for y. The negative 1 goes in for x. You use bedmass as much as you can. So we're going to add what's inside the brackets first. And then the exponent. 7 squared is 49. Oops, I made a little mistake here. That should be plus 1. And then once you've done using bedmass as much as you can, because you can't take the 49 and add the 1 because the 49 is attached to the a, so they're not like terms. Now you're going to solve this equation. So subtract 1 from both sides. And divide both sides by 49. So that makes a equal to negative 1. So equation is negative 1 x plus 8 plus 1. Sorry, I said that was the last thing you needed from this unit. What I meant was that's the last thing from this unit for quadratics. The very last thing was just remembering how to evaluate these exponents. So a negative exponent means you flip the base. And then make it a positive exponent. So since the exponent is negative, the base is no longer 3, it's 1/3. And now the exponent is positive 4. Both the numerator and the denominator get the exponent of 4. 1 to the 4 is 1, 3 to the 4 is 81. For question B, any base with an exponent of 0 is equal to 1. Once again, with a negative exponent, we're going to flip the base upside down, change the exponent to a positive. Both the numerator and the denominator get the exponent of 3. So it's going to be 3 squared over 2 squared, which is 27 over 4. Oops, sorry. It's 3 to the 3. Both numerator and denominator will get an exponent of 3. So 3 to the 3 is 27. 2 to the 3 is 8. So, Unit 3 was a short unit, so that's all you need to know from Unit 3. If there's anything you didn't understand, make a note of it and ask your teacher during the next day.